There's more to plants and trees than meets the eye. Even though you can't see it, plants and trees provide the oxygen we need to breathe and sustain life. In return, we exhale the carbon dioxide they depend on to grow. Many industries also depend on carbon dioxide for their growth. It's used in welding and steel making, to carbonate soft drinks and freeze foods, even as an atmospheric gas in greenhouses, just to name a few. One reason why carbon dioxide is so versatile is that it can be used as a gas, a liquid, or a solid. As a gas in the air we breathe, carbon dioxide is safe. But if it isn't handled or used properly on the job, it can cause serious problems no matter what its form. Anyone who works with carbon dioxide must understand its properties and hazards and follow strict safety rules. As the largest industrial gases company in North and South America and the leading supplier of carbon dioxide, Praxair can help you understand and avoid these potential hazards. When working with carbon dioxide, you need to guard against three possible hazards. First, carbon dioxide can cause asphyxiation by reducing oxygen concentration in the air. Second, carbon dioxide can cause high pressure and rupture pipelines. And third, carbon dioxide's extreme low temperature can also make metal brittle, weaken pipes and lines, and freeze human skin. But by following specific guidelines, carbon dioxide can be used safely and effectively. What are the guidelines to follow? How can you recognize potentially life-threatening situations? And how can you avoid them? First, let's discuss asphyxiation, a danger anytime you use carbon dioxide. Asphyxiation means to die or become unconscious from lack of oxygen or other breathing problem. This can happen without any warning or sign of danger. Because carbon dioxide has no color or odor, your senses can't always tell if it's present or how much is in the air we breathe. Releasing carbon dioxide outdoors may not create an asphyxiation hazard as long as air circulation keeps oxygen levels high enough. But indoors, especially in low areas or confined spaces, carbon dioxide can force out oxygen. That means anyone inside these areas risks asphyxiation. Also, keep in mind that carbon dioxide is 1.5 times denser or heavier than air, so it can accumulate in low or confined areas. In a confined space, it will displace the air inside, leaving a potentially deadly trap for anyone who doesn't follow the recommended guidelines for such spaces. Without proper ventilation, carbon dioxide gas will stay in this space for a long time because oxygen cannot displace the heavier carbon dioxide. A confined space is defined as an area large enough for bodily entry, is not designed for continuous occupancy, and offers limited means of entry or exit. The highest risk for entering a confined space is during non-routine work, such as maintenance, welding, or repairs. How much carbon dioxide is safe? According to OSHA, the United States government's Occupational Safety and Health Administration, the permissible exposure limit for carbon dioxide is 5,000 parts per million, or 0.5% time-weighted average. That's the acceptable concentration for an 8-hour workday and 40-hour work week, at which nearly all workers may be repeatedly exposed, day after day, without adverse effect. The American Conference of Governmental Industrial Hygienists recommends the same level. It also recommends a short-term exposure limit of 30,000 parts per million, or 3% carbon dioxide for 15 minutes. Higher levels will cause symptoms such as increased respiration rate, headache, dizziness, and high blood pressure. At a level of 10% or more, carbon dioxide will eventually cause unconsciousness. To make sure the carbon dioxide level is safe, use a carbon dioxide analyzer. Take readings about 5 feet above the floor at several places and average the results. In smaller spaces that are less than 5 feet, monitor all areas. In addition to controlling carbon dioxide levels, it's also vital that you monitor the air and keep your work area well ventilated, so the oxygen level is between 19.5% and 23.5%. At just under 19.5%, the effects of reduced oxygen don't take effect quickly, and they can be reversed. But if you're exposed to an oxygen level of 15%, you can become unconscious without any warning. It can happen so quickly, you won't be able to get out or act fast enough to protect yourself. At any oxygen level less than 12%, most people die unless they're quickly removed and revived. Use an approved analyzer to make sure the oxygen level is at least 19.5% before you let anyone enter. Check the air above and below the entrance and around the interior. Do this from outside, and continue to monitor the inside atmosphere until all workers in the confined space leave. To work in a confined space, you also should have a confined space entry permit. A confined space with potentially hazardous conditions such as atmospheric are known as permit confined spaces. And you should also follow all other safety regulations. Avoid danger by closing valves and disconnecting all of the vessel's lines. Just shutting off a valve may not protect against asphyxiation in a confined space. Valves leak, and they can be opened accidentally. To be sure, isolate any confined space connected to any gas source other than air. Block lines off with a blind or blank flange before anyone enters. Then ventilate the space. Ventilate the entire vessel with air, top, middle, and bottom, before you let workers enter. Get air circulating with fans or any other similar device. Also, make sure anyone entering the confined space has a safety harness with a lifeline. Below an oxygen level of 19.5%, everyone must have an airline respirator or self-contained breathing gear. Don't rely on dust or gas masks. They're not effective. And never let a worker enter a confined space unless someone else remains outside as an attendant, and they're trained in rescue operations. Asphyxiation won't be a threat if you follow these simple rules and train yourself to recognize potentially dangerous situations. Let's review them again. Before you start any work, have someone approved by management fill out and post a work permit. Make sure you disconnect and remove all pipes, hoses, or ducts connected to the enclosed space. If lines can't be removed, insert blinds or install double block and bleed valves. Use an approved analyzer to make sure the carbon dioxide level is no higher than 5,000 parts per million, and the oxygen level inside is not below 19.5%. Check the air above and below the entryway of a confined space and around the interior. Make sure any work outside the confined space will not affect the atmosphere inside, such as by drawing in harmful gases through ventilation. Take these steps from outside and continue to monitor the inside atmosphere until all the workers in the confined space leave. Use the right equipment for entering a confined space. For permit-required confined spaces, it's important to understand what equipment to use and how to properly operate it. Also, never let anyone work alone. Entering a confined space requires workers who are specially trained and the presence of a certified rescue team. A second potential hazard to guard against is overpressurization. Any pressurized gas can be dangerous, even air, but it's especially important to protect against overpressurizing carbon dioxide. For example, carbon dioxide used for refrigeration is delivered as a liquid by pipeline. By accidentally trapping this liquid between closed valves without safety reliefs, it will warm and expand. Without enough room for expansion, the pressure can rupture almost any distribution pipeline. You can prevent overpressurization by installing relief valves in any pipe section you can close off that contains liquid or cold gas. Also, design your pipelines to hold the highest possible pressure, so they are rated for maximum working pressure and minimum temperature. This means choosing equipment like regulators, hoses, and liquid transfer lines made only from materials designed specifically for carbon dioxide. Then follow the manufacturer's recommendation for sizing, rating, and application. Systems that handle liquid carbon dioxide should be made from materials recommended by the Compressed Gas Association, which develops and promotes safety standards and safe practices in the industrial gas industry. If your pipeline is connected to any vessels, hoses, or other equipment not rated for maximum pressure, protect it by placing pressure relief devices in the supply lines. And every pressure regulator needs backup protection downstream, such as a safety relief device in case the regulator fails. Pipelines carrying liquid carbon dioxide have a vaporizer between the tank and the pipelines that changes the liquid to a gas by warming the cold liquid carbon dioxide. Make sure the vaporizer is large enough to prevent any liquid from passing through, even at the highest demand rate. The third potential hazard is handling carbon dioxide at extremely low temperatures. For example, carbon steel pipe loses its toughness when it's cooled far below ambient temperature. It can break or even rupture under pressure if it is hit or even torqued with a wrench. Contact with pipes that contain carbon dioxide also can freeze flesh. Make sure everyone working with or near these cold pipes wears long-sleeve shirts and insulated gauntlet gloves. When cold carbon dioxide liquid or gas isn't enclosed by a pipeline, workers need to take added precautions by wearing a face shield and insulated gauntlet gloves. If you're handling carbon dioxide in the form of dry ice, use tongs. Wear long-sleeve shirts and eliminate cuffs from trousers so they can't catch or trap dry ice. And store it in well-insulated containers. Be sure these containers are not airtight because gas that forms can create a high-pressure hazard. Let's review the three basic hazards of using carbon dioxide. They are asphyxiation, overpressurization, and personal or material contact with carbon dioxide. Avoid asphyxiation by requiring work permits and confined space entry permits anywhere there's a confined entry. Isolate confined spaces from all piping except breathing air lines. Check the air in confined spaces before you enter. Have an attendant stay outside a confined space when workers are inside so they can get help in an emergency without leaving. Use a carbon dioxide analyzer to make sure the carbon dioxide level is not more than 5,000 parts per million. Use an oxygen analyzer to make sure the oxygen level is not lower than 19.5%. And check for new confined spaces, especially during shutdowns, maintenance, or repairs. To prevent overpressurization, install relief devices in lines where liquid can be trapped. Use pipes and controls that can hold the highest possible pressure with regulators and safety relief valves installed ahead of hoses and low-pressure equipment. Prevent damage to pipelines, valves, hoses, containers, and other system parts by using materials that can handle the extreme temperatures and pressure. Avoid personal contact with carbon dioxide by wearing eye or face protection and insulated gauntlet gloves. And wear long-sleeve shirts and trousers without cuffs. Your Praxair representative can provide a wide variety of information on carbon dioxide safety, including material safety data sheets. The guidelines are simple to follow. Make sure you do. We want you to get the most from your carbon dioxide system safely for a long time to come.